Hi everyone, and welcome to another video of the SAFI webinar series. In this video, we're going to have an overview of member deflections. Deflections are only verified for the service limit state load combination type. When the SLS option is selected, the user must specify the combination category according to the deflections verification. When automatic option is selected, the program will automatically determine the category depending on the type of basic loads included in the combination. The Deflections tab on the Design Codes Parameter dialog box serves to specify default values of the various deflection criterions for the 4 supported categories of loads. These criterions can be modified for specific elements of the structure using the Member Attributes command. By default, a deflection is calculated based on the physical member length when defined. However, the user can specify a different option or a custom value. It is possible to calculate the deflection parameters on a selection of members using the recalculate command. This command will calculate the unsupported lengths considering that the elements that intersect the member are lateral supports. Let's start our demo. The general deflections parameters can be edited using the Design Codes and Standards Parameters command. The Deflections tab in this dialog box allows to specify the default values of the deflection criterions for the 4 supported categories of load combinations, including the dead loads, the live loads, the total loads, and the win loads. The user can edit the deflection parameters for individual members or a selection of members using the Member Attributes command. The Deflections tab in the Member Attributes dialog box allows you to modify the member attributes related to the verification of the deflections. The attributes which can be modified in this tab are the method to determine the effective lengths along the axes Y and axis Z and the deflection criteria for the different loads. The user can specify a relative or an absolute deflection criteria for the effective length calculation method. By default, the software uses the physical members option when available. In this case, the effective length will be equal to the length of the physical member from which the selected members are part of. When the member is not part of a physical member, the length of the member is used. The first option, None, prevents the program from performing any verification of the deflections for the selected members. For the Use Members option, the effective length will be equal to the length of the member. For the last option, Custom Value, the user must specify the effective length to be used for the deflection verification. The user must also provide a reference joint for which the deflection will be computed. If the reference joint is 0, the deflection is computed from a fixed point. Deflections are verified for service limit state load combinations. Service limit state combinations, or SLS, are specified from the load combination type parameter. When the SLS is selected, you must specify the load combination category with respect to the deflection verification. Select types of loads contained in the load combination refers to the corresponding deflection character used. If the option None is selected, no deflection verification will be made for this combination. When you select the option Automatic, the program will determine the category automatically based on the type of basic loads present in the load combination, and the calculated values will be displayed at the right of the option list. Let's run the analysis. The deflection and numerical results are available in the Analysis tab on the Results toolbar. We set the minimum limit state ratio to 0 to display all the results. In this numerical table, the member deflection results are available for all the members for the service limit state load combinations. The load type used for the deflection calculation is displayed in the load type column. The deflections in the Y and Z axes are displayed in these columns. The last column represents the maximum of all serviceability limit states, which is the maximum of the service limit states along the Y and the Z axes. When we run the analysis and we use the steel, aluminum, or wood module, the deflection limit state is added to the other limit states in the limit state summary. In this example, we use the steel module, so if we check the limit state results, we can display the deflection limit state graphically. If you run the optimization of steel or aluminum, the deflection criteria are verified as well. For example, if we want to check this column, we can see that the effective length calculation method uses the member length. So, it doesn't use the physical member length because this physical member is supported in the directions Y and Z at this specific joint. For this physical member, we can see that the effective length calculation method along the Z-axis uses the physical member because there is no support in the direction of Z, and for the Y direction, we use the length of the member. Now let's check this beam. By default, members use the physical members to calculate the effective length. If I subdivide this member into two divisions while keeping the new members as physical members, if I check the deflection parameters, we can see that the effective length still uses the physical member. This is the correct value because this member doesn't have any support in the Y and the Z directions. Now let's assemble this member, and this time I'm going to subdivide it into two independent members. In this case, if I check the deflection parameters, we can see that the calculation method used the physical member, but these two members are independent. So, the effective length in this case is not correct. One way to fix this is to specify it manually. We can specify a reference joint. For example, this is the joint, joint 18. So I specify here a custom value, and I will put joint 18 as the reference joint. I will also specify the length of this member, which is 7.5 meters. I can do the same for the other direction. So here, 18 and 7.5 meters. That's one way to specify the right deflection parameters when we do different operations on members, including subdivision or assembling or attaching members. Now let's set the default parameter again. I'm going to assemble these two members. Let's check the parameters again. It looks to be fine. I'm going to subdivide this member into two independent members again. One way to recalculate the deflection parameters automatically is to use the command recalculate, which we can find in the edit menu here. First, I need to select the members that I need to recalculate the deflection parameters. Then, I select the command and I check this box, Recalculate Deflection Parameters. Then I click OK. If I check the member attributes, we can see that the software calculated the values of the effective lengths automatically and specified the right reference joint. Thank you for watching, and catch you in another one of our webinar series videos.